The Glenn L. Martin Wind Tunnel here at the University of Maryland is here because Glenn Martin, who is the Martin of Lockheed Martin Corporation, was operating one of the very large aircraft factories that existed in the United States at the end of World War II. And he gave a large amount of money to the University of Maryland to promote education in the sciences and engineering. And as a part of that gift, he stipulated the construction of the Glenn L. Martin Wind Tunnel. We have been continuously looking for the places that we can participate in industrial development as well as research efforts. Our involvement in research is important to the people we support in design studies because it allows us to stay up to date on the latest ways of correcting for the effects that are inevitably present anytime one does measurements.
Genovation is a very forward-thinking, nimble, small electric vehicle company. We develop very high-performance, state-of-the-art electric vehicles and electric vehicle components. We're trying very hard to push the state-of-the-art, also in aerodynamics, and that's why the University of Maryland's wind tunnel has been so helpful for us. It's a facility that's in very high demand, but they were really helpful in terms of accommodating our schedule and allowing us 3 days of testing that worked out very positively for us. We developed a ground-up vehicle called the Genovation G2. It's probably the greenest concept vehicle on the planet. We use soybean resin and basalt fibers to make the body. And we had it in the wind tunnel a while back, and the data was very, very impressive. It validated our computational fluid dynamic analysis models and indicated that it would be one of the most aerodynamic vehicles ever made.
The wind tunnel has brought tremendous value. My expertise is in computational fluid dynamics, and I primarily simulate what a wind tunnel will do when I'm developing different types of vehicles and systems. There's no substitute for the real thing. And any simulation is just that. It's a simulation, it's an approximation. And the wind tunnel is able to allow us to calibrate our models to make sure that we're getting accurate data. And it's able to give us that real world stamp of approval so that we can know that we're actually going to be able to get the performance that we're looking for. We're here today to verify the aerodynamic performance of a tractor trailer model that we built that is specifically designed to verify the performance of add-on aero devices that reduce fuel consumption for Class 8 trucks. The equipment that they have here is second to none. The lab itself has very accurate force measurement equipment, and the tunnel itself is able to test a wide variety of different types of systems and vehicles, making it an ideal type of location to test vehicles like the ones that we're looking at today. More importantly, however, the staff here is very experienced, more experienced than any other group that I've ever had the opportunity to work with, and we've been able to leverage that experience to be able to get more out of the test than just some numbers at the end of a report.
For General Motors competing in the marketplace, it's critical that we have beautiful cars that are also efficient and have high fuel economy. Aerodynamic development and drag reduction is critical for all of our vehicles as we try to improve fuel economy, but it's especially critical on electric and hybrid vehicles like the Chevy Volt or the upcoming Chevy Bolt. The staff at the Glenn L. Martin Wind Tunnel is extremely helpful to us in providing the testing that we need and using their knowledge and experience to produce very accurate results and to run the process very efficiently. We can get a lot of work done there in a fairly short time. Most of our future product programs are actively involved in testing at the tunnel.
Looking to the future, our ongoing challenge is to combine the power of computer simulation and our power of experimental explorations. And that's particularly important here in our educational environment because it means that we need to educate our students in both aspects. Our objective is to have graduates who have knowledge of both the computational simulation and the experimental methodologies so that they can have the advantages of both in their careers.
I've been very fortunate to have the opportunity to collaborate with the wind tunnel at the University of Maryland on a number of different types of projects. The collaboration has always been very rewarding, and we've benefited very greatly from working with Dr. Jewel Barlow and the staff here at the wind tunnel.
I would highly recommend using the wind tunnel at the University of Maryland. It's very much a state-of-the-art facility, but it's steeped in tradition.